Hello and welcome to this presentation of short-lived immutable servers with Masterless Puppet. I delivered this last in London for Puppet Camp London earlier this year, and so I'm re-recording it now and uploading it so that as well as enjoying the slides you can also enjoy my lovely dulcet tones in order to narrate along with it. So let's get straight into it. I am Neil Millard. I've been programming since I was very small. Started on the ZX Spectrum, got one of my own when I was maybe 11, 12, something like that. Used my paper round pocket money to buy a second-hand unit. Disappointed to find out just 16k, I know, a massive 16k. Paid even more money then to get it upgraded to earth-shattering 48k. Those are back in the days when computers were very small and we used to play stuff like Jetpack and Attic Attack and things like that. We're talking mid-80s. Moving swiftly on after the experience on the Specky where I was learning BASIC and then onto machine code, upgraded to an Amiga 500, which is a well-known platform for computer games in the early 90s. Along with that upgrade also came floppy disks and more memory, so we had a 1 meg of memory in the standard unit, and you could store just under 1 meg on one floppy disk as well. So I've always been programming. Then I got a break into IT in 1995, looking after hardware. I was working for a computer company part of Thorn EMI, who provided EPOS, electronic point of sale hardware, to companies and shops such as Oasis for clothes and ATS, who are a tyre distributor. Victoria Wine, an off-license, I think they're still about, and a few other companies, so fixing the EPOS, tills, springs and all that great fun. Swiftly moved on to then working with office equipment. As you can see, there's a picture of a compact there on the screen. I don't think I worked on that exact model, but certainly the 2000 model was very popular with my clients at the time. And eventually moving on to the infrastructure cabling. I don't suppose many of us see those anymore. Now we've moved over to the cloud, but it wasn't that long ago when I was using patch cables and plug-in servers into racks and things like that. So, given that I have quite a strong infrastructure background with servers and that lot, and also starting very young, 9, 10 with ZX hardware, later on to the Spectrum, I was almost delighted when about 6 years ago this term DevOps gained a lot more traction and stuff. It was obviously created a little bit before then, but the fact that we could use our skills as developers and apply that to operations and infrastructure was a very exciting time for me. Also, in my spare time, I like to fly helicopters. You might notice a little theme running through the presentation and the slides if you've not seen them before. Yeah, I do like helicopters. There's me standing in front of one at my local flying club, which is not even 5 miles away from my house where I'm recording this right now. What do I like to do? I like to educate and share ideas. This is why I'm doing this talk now and why I did presentations earlier in this year. I like to automate systems. Ultimately, I'm lazy. Bottom line, if I can push a button and get a computer to do it, then excellent. I mean, that's after all why I got into programming in the first place. And most importantly of all is to have fun. If you can automate and get the computers to do stuff, great, that frees us up to do more creative activities or fun activities, or play computer games if you're so inclined. So let's move on to some meatier type subjects then. Part of DevOps is often the gap between the developer developing the code and the production server at the other end of the cycle. And DevOps is more or less everything in between. How to take that code, how to stick it onto the infrastructure, the application then gets installed on top of that infrastructure, and then some clever guys like myself come along and we stash those logs away using Logstash or something similar, and we monitor the servers and the application to make sure everything's hunky-dory. Bolt on the side this DevOps thingy where we automate all of those steps. We automate building the servers, we automate installing the application, we automate the monitoring, and we automate the logging. And just have to spend our time twiddling our thumbs or watching big monitoring screens saying that everything's good and green and a-okay. So the agenda for this presentation then is I'm going to talk about Masterless Puppet, then moving on now to how we bootstrap the whole process, a thing called modules, and this is Puppet modules and what they do and how we can use them. Hieradata is a hierarchical store of data. I'll talk a bit more about that. Roles and profiles is tying together the modules and the hieradata to create what's called a manifest. And then I shall touch on ordering and staging as part of that ordering, which can be tricky, but we'll get to that later. So what is Masterless? It is quite simply a Puppet agent that doesn't have a master. So what does this mean for us? This means that we need to have everything that we'd normally have installed on a master somewhere available so that we can install it onto the agent machine itself. The automation is to provide all the configuration files that the master would normally give us, and this is stuff like the modules and the data and the classification. And classification is where you group machines together in order to give them similar roles. This helps us in lots of ways that we'll see when we get to roles and profiles later on. So why use Masterless Puppet? Well, you might have heard of the analogy, originally attributed to Bill Baker at Microsoft, of pets versus cattle. So with pets, you'll have a server, and you know, more often in the olden days, you'd unwrap it from its box. If it was an Apple server, then that might be a truly beautiful experience. If it's not an Apple server, then it might be quite boring and you just have to work out where you're going to put the bubble wrap and things afterwards. So you've got your server, you've lovingly inserted the memory in the CPU and placed it into the rack, and you plug all the wires in and you switch it on, and of course it does nothing because it's just come out of the box. Install some hard drives, install some software, and because this is all kind of a manual-ish type process, you develop a sort of attachment to the server like you would a pet. So when it gets a bit, I don't know, bit slow maybe, you'll perform some maintenance on that and nurse it back to health. Or maybe it has a hardware failure, the hard disk dies, which is quite common, and you'll go off and get another disk, and then you'll replace the disk and make sure that because you've got that fault tolerance in the system, it rebuilds the disk and everything's all well again. And you know, if it gets ill, you nurse it back to health. It gets ill, you nurse it back to health. And then you might have this server around for 7, 8, 9, 10 years, when perhaps it's running Windows NT, and we're talking about decommissioning it because the new software's been installed. But yeah, maybe one day, but not today. So what happens when you start installing software onto this pet and you want it to serve more businesses? After all, if we've got this server around for 3 or 4 years, a lot can happen to a business in 3 or 4 years. More customers, more demand on the servers, and so we can scale up. I've illustrated that here by, we start off with our nice Robinson 44 helicopter, 4 seats, and that's all it can carry. We then upgrade the memory, we add more CPU to it, we add more hard drives, and so we just make the whole server, still one server, but we make it bigger and bigger and bigger until you end up with a massive mill sat over on the right side there. So the almost exact opposite to this is cattle. If you have cattle, it's nice. You think of it more like a cloud server, perhaps. You order your cloud server from the Amazon marketplace, it creates a server, it loads the software on for you, it's quite automatic. If you're not familiar with Amazon, then perhaps maybe you've worked with Docker, and a similar principle applies. You ask for a Docker container, it's got all the stuff you need running on it, TensorFlow maybe, or web server. It does its thing, and then, oh, somebody's hacked into your web server. Oh no, what are we going to do? Oh, that's not a problem. We close it down, we get rid of it, and we create a new one. So we can just keep, rather than having to nurse it back to health, we just get rid of it, kill it, whatever, and create a new one in its place. After all, it's really free and easy to create a new server. There's lots of them around. We can create them very quickly, and so it's not really a big deal to create a new one. So what happens when our company grows? Well, as I said earlier, we can have more customers and more demand on the servers, and at this point, because it's easy to create new servers, provided we've got the clustering and stuff configured beforehand, then we can just scale out. So rather than making each individual server bigger with more RAM and CPU, which is scale up, we then scale out, so we add more servers. So we can have 4, 5, 10, 20 servers that have got infinite more power than we could ever get to by making one server bigger. So Masterless Puppet allows us to embrace the cattle a bit more, but if we did have a master, then might that not be a pet? There's maybe one, maybe 2 of them. It's kind of like the head server that looks after all the other ones, so it does need to be looked after, it does need care and maintenance. And another thing about pets is sometimes they're a bit fragile. So things can break, and after all, you're relying on just that 1 or 2 servers. It can be a little bit more important when something fails. With the cattle model, we can rebuild a server rather than reconfigure. This is where we get the immutable paradigm from. Immutable means not changing or unable to change during its lifetime. So essentially, if we want to change anything on it, we wouldn't change it on that server. We'd rebuild a new server with all the latest settings on it and get rid of the old one. This means that the servers are also quite temporary. If they do have a workload, they get created, they run that job, that work, that whatever they need to do, and then we destroy them. Build, work, and then destroy the server. So hopefully that's covered why we would use a masterless puppet, because it allows us to embrace this temporary workload model, and we can build and destroy. very useful for the cloud. So how do we get there? How do we start the automation journey with this automated masterless Puppet agent? We have to bootstrap it. So the bootstrapping essentially is an old term really, where you get your new server, whether it's just come out of a box or whether you've just clicked build on the cloud. It needs something to do straight away. Computers are inherently not stupid, that's probably not the right word, but they don't know anything. No one's there to teach them anything, so we need to kind of give them a guide, a path in order to get moving. So with most of the Unix distros now, there's a thing called Cloud Init, which allows us to inject stuff. In the Amazon world it's called user data, and in the user data we can provide scripts, we can provide variables, and just give it a hint to our server as to what it should do next, which is usually install the OS, or a lot of the time there is already an OS, and we can get going on installing other essential bits and bobs that server needs. So if the server knows what environment it is and what its role is, it can then start on that building automation process. So I mentioned earlier about the OS, or we can start from a much lower base. So when we bootstrap, we can start with everything included, including the kitchen sink. This is called baking an image or baking in an AMI. And if you've used Packer, for instance, this is what one of the functions it will do. It's also quite similar to Docker images, where you're pre-loading everything into a disk image. So we've got everything included in there. We've got the OS, we've got the software, we've got the patches, we've got absolutely everything in there. This is great because it means that the server boots up really, really quickly. It's kind of bad though, because there's lots of maintenance required. If something changes, like there's a new patch for the software, the dev team, they've created this new minor patch that fixes a bug that was in the previous edition, it then means we need to then rebake this image. So we need to get a server, we need to create it, we need to load all the stuff on it, and then we need to take an image, which can take a lot of time. Or we can take the opposite view. We start off with the bare shell, the bare minimum that we need. So that would be an operating system, perhaps CentOS or Ubuntu or something like that. And then on top of that, we then build everything we need. And that's where you might use something like Puppet or Chef or Ansible in order to take that bare shell, take the configuration that's stored somewhere else, and then we throw everything onto the thing. And that's very much the approach that I take with the Immutable server. We want to keep the image that we're using to start from as little as possible and as simple as possible, so that we can then control everything else through configuration management. After all, we're building these things often, and as soon as something changes we can then build a server, rather than the previous model where we would have to create a new image which could take several hours and then deploy it to the system. So as part of the bootstrapping process, we've got our operating system installed. The next things we need are the Puppet prerequisites. We need Ruby, because Puppet is a Ruby gem. We need Git or some other source control software. We need to install gems. Like I said, Puppet is part of Ruby, and gems are the modules that Ruby uses. So we can install Puppet, we can install Hiera, we can install YAML, eYAML, and various other bits and pieces, Puppet librarian, stuff like that. And then once we've got those in place, we can then install the modules. These are the Puppet modules that Puppet's going to then run for us, which are reusable bits of code, to build our server for us. Once we've got all the prerequisites installed, we then move on to running Puppet itself. There's an open source repository that Money Supermarket have provided called Bootstrap, and this does the preceding steps we just covered. So it installs Ruby and the prerequisites for Puppet, and it will go off and clone a repository with all the configuration in it, and use the role and the environment in order to understand what it needs to pick up. So what we're putting together now is Puppet's going to grab the various components for us, and it's going to put them together so that we can build our server. These components, like the illustration of the helicopter there, are all discrete and separate things on their own, but when we put them all together, we'll have our working server. So the components that we need are hieradata, which is our data itself, so stuff specific to the server, what's its name, for instance. Roles and profiles, which is the reusable code that defines what components we need to plug in, and the modules is the individual components that we're going to put in together and then configure with the data defined in hieradata. Let's just slide out there, let's go back. Okay. So the configuration, I've mentioned that Bootstrap goes off and it gets the configuration. What does that look like? This is very much related to the infrastructure as code statement. So to elaborate a little bit more on infrastructure as code, there's really two bits to it. There's what the actual virtual hardware looks like. So the server, the network, the hard disks, what you're actually going to create your server out of is part of the infrastructure as code, and then the flip side of that is what each individual server is then configured to do. And this is the bit that we're working on right now. We've got our server, we've created it, and we're building it up from the configuration. So to build it up from configuration, we need to have some configuration, and that's usually done through a control repository to keep everything in the same place for us to be able to control what that server looks like. Now in places I worked at like MSM, they'll have a bigger control repository that will contain all of the shared components. So regardless of what the server role is within the organization, the config is in that repository somewhere. This does create a lot of turnover of the code in the repository, but not everyone's editing the same amount or the same server at the same time. This does allow for a lot of shared code to exist, and therefore reduces duplication across teams and things. If you want an example of what a control repository looks like that I have on the screen here, we can go to the URL github.com neilmillard puppet-docker host, and you'll see some example config there. So this hieradata, I've mentioned it several times now. It allows us to separate our code, the things that makes our organization or our server unique, and separates that from the code. This enables us to very much have the two components here of the hiera, the data, the individual names of stuff, and the code, which is the Puppet modules. Allows us to reshare the Puppet modules, which you'll see soon enough. So in this example, I've got some data on the left hand side right here. I've got a bit of Puppet code right here that defines, in this case, using Gareth R's Docker module to run a Docker container. And through a mixture of using defaults and also our data over on the left hand side. It mixes those together and we come up with our actual Puppet code that is going to execute. So the fact that we can separate our data from the code means we then have code reuse with these modules, and we can look up the various variables and stuff that make our module or server or container unique to us. The automatic lookup is done based on the Puppet class name, in this case profile Docker containers, and the variable name, which is containers. When we get this information together, profile Docker containers, hieradata will then be instructed by Puppet to go look up what that data looks like. In this case, we've got the key here, profile Docker containers, and it'll take, it looks like it's looking for an array here or a hash, so it will take all of this data here. With the automatic parameter lookup, this means we don't have to specifically use Hiera commands in order to pull that data in. It will just look it up, like I said, based on the class and the parameter name. Hiera does rely on files for it to store the data in, and with Hiera comes a configuration file that tells it what files to look for. So this is not the most complicated hieradata file that exists, but is certainly not the simplest. So if we ignore the fact it's got eYAML and the eYAML chunk here, that's all tied in together, and just focus on YAML. So the back end of YAML, we have a YAML configuration here that says I'm going to look on the server into this folder for my data. Then the hierarchy, which is where Hiera gets its name from, then says I'm going to look in this hieradata folder, and the first thing I'm going to look for is a file that has the name of this variable initEnv and this variable initRole. So if our environment was dev and our role was web, it would look in etc puppet labs puppet hieradata dev web.yaml with a slash, separate folder and slash, obviously. If the file exists, it will read it and then it will look for those automatic lookup keys in that file. If it cannot find the key, either because the file doesn't exist or because the key is not in that file, it then goes on to the next step. So it will then open a file called web.yaml. Again, it will look for the keys in that file. If they don't exist in that file, or the file doesn't exist, it will then go to the next file, which is just going to be called dev.yaml. Same again, looking for the keys, and if they still don't exist, it will then go to the common.yaml file in order to look for those keys. If the keys don't exist at that point and it's mandatory, then you'll get an error in your Puppet code. Otherwise it will use the default as defined. So moving on to roles and profiles, this allows us to use modules in a very much a reusable way. There's a very good talk by Craig Dunn, who still does or used to work for Puppet, I'm not sure now. The link on the screen there, which will go into a bit more detail, but at a high level we can have a profile at the implementation layer here that includes classes, which is modules and resources. So the profile might be a specific configuration for some software, like a Jenkins server, or a Tomcat server, or a LAMP setup stack, or a Postgres server. So the implementation. each one of these, more often than not, is just pointing straight to a Puppet module, like Jenkins or Tomcat or Apache, as you can see. In order to then link these together, so in this case Jenkins actually says Jenkins and Tomcat, we would then have a role that can include the profile of Jenkins. So in this case we've got two servers called Jenkins. They both have the same role called CI, and CI contains the Jenkins profile. Quite a straightforward installation there. However, we also have some web servers. We've got a couple of web servers, and they've got the role of front end. That front end then includes the profile of LAMP, and LAMP then goes off and installs Apache and MySQL. If we had some web front end servers, say the middle tier application servers, then they could point to the app role, which would install Tomcat and LAMP. And Tomcat would then install Tomcat and Apache, HTTP and MySQL. And it would be quite a fat server, but we can start nesting things at that level. And at the very basic example on the end is the database. Has a database in it, contains a database profile, and that installs Postgres. In this example, if we wanted it to install MySQL, then we might have a profile MySQL that could then be included in DB, and it would go sort of DB MySQL instead. So you can reuse bits of code and layer them appropriately based on the role of the server. So these modules at the bottom of that diagram, where do they come from? Well, Puppet modules are stored on the Puppet Forge, or you can have your own private modules on source control, such as GitHub. The modules have a very specific structure which allows us to share and reuse the code in those modules. They're split into 4 main sections. There are other extensions to the modules should you need those, but the main sections are the manifests, which usually as a bare minimum contains an init.pp file. You might have a params.pp in there, and then you might have other pp files in there, which are Puppet classes, one for each file. Also, Puppet defines can also be in that folder. Then you might have a files folder, which contains just the basic binary files, or files that don't need any alteration that the module might install, like in the case of a HTTP server, it might be the default Apache configuration file. However, because we're likely to want to customize this, you're more likely to find those sort of files under templates. The advantage of using a template is we can then take that default file and we can take our variables that we've got from our hieradata and inject those into the templates, stuff like the server name, where the web root is, and other variables that we might want to put into a configuration file for the application. And then in a module you may or may not have a lib folder. This is where we can specify our own functions written in Ruby that Puppet can then call specific for our module. This is kind of useful when you've got more complicated setups, like a MongoDB cluster, for instance. Rather than breaking out into an exec type, which Puppet supports, so you can run commands directly off of the command line, you might write a function in Ruby and stick it in the lib folder in order to do that functionality instead. That way you're saving your security risk potentially from just running an exec or jumping outside of Puppet. We can get the modules from the Forge and from our source control. by using Librarian or R10K. Both of those applications use a Puppet file where you define where you're going to get the modules from, in this case the Forge, and then what modules you want, including a version number, which is not mandatory, it's optional. You'll just get the latest version if you don't specify one. Obviously we're all about version control, we like to know exactly what's going on our server, so it's good practice to specify a version. Librarian also supports getting modules from a Git source, so you can specify Git URLs in there as well. Puppet files are stored in the main config repo, along with the YAML and the roles and stuff like that. So once we've got all of our data, all of our control repos and all of our modules together on our box, the agent is then ready to compile the catalog. So it does this by reading through from start to finish all of the code, compiles it with the data, with the manifests, it pulls it out of all the modules and creates a graph of tasks that it needs to execute. Those get compiled into the catalog, and then the catalog gets passed to the apply, which will then query the state on the server, check whether it needs changing or not. So if you've run Puppet multiple times, which on a normal agent you might do, if somebody's logged into the server and edited a config file, for instance, that change is going to be wiped out because it will be picked up by the query status of the apply, compared against the catalog that it's just compiled, and if it's different, it will then go off and change it as per the catalog. This means that our server should never drift from the configuration that we've set for it, even if people go in and start messing with stuff. Of course, if it's not managed by Puppet, then Puppet's not going to know about it regardless. So in that case, it's slightly out of scope, and you might want to update your configuration to bring those files and services and whatever into your configuration. So the steps that Puppet Apply goes through, it might be useful just to follow through the individual files and everything that it looks up in order to get to the compiled catalog. So in the example control repo that I've got, there's a manifests and a site.pp, which is the first file that Puppet looks at. If you're using Vagrant, this is sometimes called default.pp, but the agent by default uses site.pp. All I've got in my config is these 3 lines: node, which is the node definition, our default node. After all, it's the agent and it's masterless, so we only have one node to worry about, and it's this one. But what is it? It's going to do a hiera include classes. So it's going to go off to the classes file using hiera. It's going to go off to its files using hiera, and it's going to look up the classes key in hiera, and classes key will come back with something for us. So remember, this is the hiera config file. This is the files that the hiera is going to look for until it finds classes for us. So it's going to go into this hieradata folder. It will start with our environment, which we've defined using the boot data. If you recall, we've told the server what environment it is and what role it is to play in that environment, and that's all it knows. So we can plug in the environment and the role, or just the role or the env, depending on what files exist or don't exist, until it finds classes. This is the exact steps it's going to go through to find classes for us, and in this case it's going to go find it in yes, next slide, it's going to find it in the docker host.yaml. Docker host is the role that I've given it in this example. So hieradata is going to load docker host.yaml, it's going to open that file up and it's going to find classes. And inside here, classes has been given the value of role : docker host, which is a Puppet class. So under the hieradata, the init role is docker host. Again, there's the repo that you can look at this for. And the init role docker host gets written to a fact for init role, so that factor gets involved and Puppet can therefore look it up. It's going to look through these files for hieradata. It's going to start with the docker host.yaml because that's the one with the host name in it, and if it can't find it in that file, that's when it goes off to common. So it's opened it in there, and our role class is role docker host. At this point it's going to go off to classes, and it's going to go auto load a Puppet module called role docker host, and it'll open up this file and it'll find this Puppet code in it. So if you recall from our big slide earlier, roles contain profiles. So we are including in this docker host role a profile of base, a profile of OS limits, a profile of Docker base, and a profile of Docker containers. We're also including a class which is a profile called swap file, but because this needs a specific argument, in this case we're telling it to run before base, we're including it this way. There's lots of ways of specifying ordering in Puppet, but we'll cover those off in a few slides time. So taking the example here, we've got our role docker host. It's including profile docker containers. It will then look up that and it will find class profile docker containers, which needs containers, and that's going to create some Docker containers for us. Roles always contain profiles and nothing else, and we can use include like we have done here, require, which is like include, but it runs and ensures it is finished before it processes anything else in the class. Or we can use class if we need to send extra arguments to our class. So here's the flow summary in picture form. We start off with our role fact, which was docker host. It then loads site pp from the agent's perspective, which then tells it to go do a Hiera lookup. The Hiera lookup then takes the role fact, passes it to Hiera, looks up the role.yaml, which is docker host.yaml file, and looks for the classes variable, the data string in there. The classes then contains the role class that we need to look up. Puppet then loads that role class, which then includes a bunch of profiles. At that point, we then have a working catalog that's ready to apply. So we've got all of our individual data from the hieradata, such as the colors, the size, the name of the server, and all the other bits that make this server unique based on the configuration. We've got our roles and profiles, which are all the components put together, and we've got our modules, which are referenced by our profiles in order to contain the actual instructions of how to fit it, install it, and get it all working. So by default, Puppet does all this. Once it's got its catalog, it does everything immediately, simultaneously, which can create problems when installing various bits and bobs. So a common pattern that we have is to install the software, configure the software, and then ensure that, in this case, it's the NTP service, so that the service is running. It would be a similar idea if you were going to install a web server, configure a web server, and then ensure that the web server is running. Same idea. Dependencies, therefore, they need an order, they need to know what to do. If you just try and install, configure and start the service all at once, chances are it's going to try and start the service before it's even installed, and it definitely start the service before it's configured it. This might mean that you'd end up with a website with no pages on it or something like that, even if it got as far as installing the software. So we can use various symbols within the code in order to control what it's going to do and in what order. We can also use English, which is similar, maybe easier, maybe not. So using the keyword before, we can specify an ordering, and we can also specify require. Now these do two completely opposite things. So in the example I've got on the screen, we have a class which is going to install SSL for us, whatever that is. It's got a variable in there called installation directory, and we've specified two of these ordering directives. We're saying that class installer requires exec unarchived source. So before you do anything with install SSL, we require that the unarchived source is done first. And then we're saying before it file copy init file. That means that class SSL needs to finish before the file copy init file is done. Now there can be some confusion by using the word before. I mean, does that mean it runs before us, or do we run before it? In this parlance, we run before it. If it's required, then we require it first. Then we run before whatever's following us. Okay? So to simplify this a little bit, you can also use these dashed arrows. So by laying out the code, so we would have our unarchive up here, then we can have a dash, then we have our install SSL, and then another dash and an arrow, and then under here we would define our copy init file. That way you're reading the code in the order that it's executed in. These are very important. If you leave these out, then that won't be the case. You can read it in that order, and indeed Puppet does read the code in that order, but it'll try and execute it all simultaneously unless you have these arrows included. The arrows aren't there, everything else is attempted at the same time. So this is great, but doesn't cover all use cases. In order to give an extra level of ordering to our Puppet manifest, we can also use stages. Now stages are a way of having completely separate manifests execute, and then we can apply ordering to those execution stages. I've got a warning there because it can cause dependency cycles. If any of your code refers to another module that's in another stage, it will break. If you need some dependency that's in a different stage, then you must enable the stages to sort that ordering out, not specify it in your code. So as the catalog compiles, it's going to run each stage based on the order that we specified in the stages, and there is an example of this in the repo. And like I said, ordering across stages will break. So in this example here, we can see that it's compiled the catalog. It's then got a stage called swap file, which has run some code, and then after that we've then run the main stage. If you don't specify what stage anything is in, it ends up in the main stage. By default, that's what happens. There's only one stage, it's called main, everything's in stage. So why are we doing this? Well, if we've got a T2 micro or even a T2 nano, the amount of memory available on these Amazon instances is very small. I think the micro's got half a gig and the nano's got even less than that. So Puppet itself needs quite a lot of memory in order to pull the catalog in and hold it in memory. So if you've got a large catalog for it to compile, like you would have if you just had the main stage, it would run out of memory before it's loaded all of the catalog. So on these smaller boxes, what we can do is we can create a swap file, and we can use Puppet stages in order for it to compile a much smaller stage, install a swap file, and then once the swap file is active, it then goes off and compiles the next stage, and then it's got enough swap memory to do that in. This is another reason why you can't have dependencies across stages, because it won't even know about it. The stages are only in memory one at a time. Anyway, hopefully that's useful if you're running on the smaller EC2 instances. So what we've covered, just to wrap up, we've covered Masterless Puppet, what it is, why you would use it, how we bootstrap the process, whether we bake everything at the beginning or whether we're baking the bare minimum. We then covered Puppet modules, what they look like and where they come from. We talked about hieradata and how it stores your data away from the code so that we can reuse those modules again and again and they haven't got anything specific in them. We then talked about roles and profiles, how a role will define what the server role is and it contains only profiles, and then the profiles that have the business logic in there of what is needed in a profile, which then itself calls the Puppet modules. We then spoke about ordering and how that can be used so that Puppet doesn't try and do everything simultaneously. It will do things in a certain order, but it does need to be told what that order is. For instance, install the software, configure the software, and then run the software. And then just to round off the bottom, we created a small about stages in case we're running on very small instances, and the stages gives us a little bit more control over ordering. So I've been Neil Millard. I've been speaking about immutable servers and masterless Puppet agents. I hope this has been really useful and informative to you, and thank you for listening. Bye bye.